Hello, everyone. Come up with an interesting topic today: real-time intelligence in Microsoft Fabric. So, why this matters? So, I want to demonstrate building a solution inside the Fabric, from setting up the data storage to detecting anomalies instantly. All right. So, why this matter in real gas turbine? For example, let's take it that as a business case. You can also go with a variety of businesses manufacturing, automotive industry, um, fraud detection, operations efficiency, finding anomalies, and etc. So I'm just taking a business use case now. In real gas turbine, sensors constantly send vibration data. High vibration can be like hearing a strange noise in your car's engine, so it's a sign something's wrong. Um, Today I'll simulate those vibration events and I'll show you how they flow through Microsoft Fabric in real time. Okay, so I'm into my workspace. So I've already created a project, real time turbine monitoring. So I'm going to create a um, where Eventhouse, Eventhouse stream turbine. Or we want to ingest the data. All right. So let's leave this now and go back to your workspace again. Project. Okay. So now I want to create another item, event stream. So we want to stream this data in real time. All right. So let's create an event stream. This is like a setting up the highway where data travels before reaching the storage. All right. Event stream. Let's call as turbine. Okay. I'm adding a custom endpoint which acts like our factory's front gate. It's where the stimulated turbine sends the real readings into the fabric. So there are many um, external connections where you can use in real time. So this time I want to stimulate this. So therefore I'm going to use the custom endpoint. I'm not going to discuss all these settings and etc etc. So let's go to use the custom endpoint now. Let's call this turbine stimulator endpoint, something like that. Let's add. Okay, since um, we don't have a real turbine here, right? So I'm generating a stimulated vibration event. Each event is like quick message containing values such as vibration level, temperature, timestamp, etc. These are sent directly into our custom endpoint, so which then streams them into um, Eventhouse. We can um, send them into the destination. I'm going to walk through now. Let me pause for a second. All right. Um, so this is a code. I'll send you a link. So as we don't have a real turbine data or turbine to connect, I'm trying to stimulate this using the code generator. So you need to run this, right? So you need to bypass these with your connections. So take this code and add your connection. So you can get this connection as soon as you publish. Let's publish this. So all right, so here you see a basic details you need to use. Enter ID authentication, where just grab your hub name, pass event hub name, yeah, replace it with your event hub, and pass your key. very important. Um, Pass your key. Okay, so I'm pass this per second and I replace it my um run and generate the events. Okay, all right, I just copy this. Let's All right, so I just copied into my Python code. I'll share your link later. So let's pass this into destination now. Let's add your destination as Eventhouse. Create something called Eventhouse Turbine. Name an Eventhouse called Eventhouse which previously created. If you haven't created, you can create new. And let's pass this and create a table, something called Turbine Vibrator. Okay, and save this. So let's publish this. Okay, let's wait this to sync up. All right, all right. So now this became an active, right? So here you see the settings. So you can change your event throughput. You can set the level of optimized performance if you want from source to destination. You want to stream. So I'll go with the medium for now. All right. So let's leave it this now because it seems like I use pretty much it. So what I did here is I created a destination table. Now mapping where the event house this event should land in Fabric and transforming them on the fly and make sure it's perfectly in the right table format. So creating a table and defining a schema, KQL database. Think of a table like spreadsheet. Each row is reading from Turbine and each column is a specific measurement like RMS, vibration or temperature or timestamp and etc. Okay, so we did this. So now let's change this to live, be active. Now run your code. Yeah, I see it's signing an event. All right, let's refresh these. Yeah, you see the data streamed very quickly here. You can also see data insights. The events are passed. I'll just pass a moment. No, let's go with let's query this now. Let's query these. I'm going to pick it up. KQL notebook. Query. Sorry, it's workbench, not a notebook. Okay, so no. So actually, you can go to the Eventhouse turbine. So let's write. Is going to sync this data. Right. So you see your data was ingested, right? Data was ingested. If you want to open with real-time dashboard, you can do it. You can name something turbine monitoring. Yeah, you can also do a top of many things. You can set parameters, yeah, etc., etc. So let's, for now, let me try to query this with code basically. Right. So I have a little code here. Copy the code. All right. Let's change this to Turbine, which we created, and let's execute. So as you see, this specific time, this is an event it's created, and basically it's checking if threshold is more than 5. Um, um, it's grouping and showing the numbers here. So we may you can analyze your data here. So in this way, you can analyze and find the anomaly. Yeah, so you can actually add an usual if you want. Change the bar chart. See, yeah, you can change X column to ID. Change white column to peak. Yeah, can change the frequency. All right, and you may see the turbine one is speaking a lot. So that's how we can compare. Um, oh, I hope you liked it. Thank you.